Good afternoon, everyone. Welcome to another lecture of the course Artificial Intelligence in Industrial and Management Engineering, which is offered as part of the NPTEL MOOCs program. I am Dr. Deepa Philip from IIT Kanpur, and today we are going to be part of the first lecture, the first week lecture, and the title of today's lecture is Introduction to Industrial Management Engineering. Since this course is focusing on the applications of AI in the industrial engineering side, we need to also look into a brief introduction of IME or Industrial Management Engineering. So, without any further delay, let us get into the topics today. So, first let us talk about the understanding industrial engineering, that is today's topic. Okay. So, there are many ways we can talk about this, but let us start with the formal definition. Okay. Formal definition. Okay. So, let us call it as the institute, this adopted by Institute of Industrial Engineers, okay. This is also known as IIE, and also the American Institute of Industrial Engineers, or AIIE, either one of them, both of them follow the same definition. The definition kind of goes like this. Okay. IE is concerned with the design, improvement and installation of integrated systems of people, materials, information, equipment and energy. Okay. So, the first sentence of this definition says it is concerned with the design, improvement and installation. Okay. You design, you improve and you install of integrated systems. The systems are integrated, not standalone systems. Integrated systems of people, human beings, materials, information, equipment and energy. Okay. So, that is the first sentence. Then second part of the definition is it draws upon specialized knowledge. It draws upon specialized knowledge and skill in mathematical, physical and social science together with the principles and methods of engineering analysis and design to specify, predict and evaluate the results to obtain such a system. Okay. So, what the second part of the definition says, it draws upon specialized knowledge, it requires specialized knowledge and skills, okay, in mathematical, physical and social sciences combined, they are together, the skills in all the three combined together, and you combine that with the principles and methods of engineering analysis and design. Why do we need all of this? To specify, predict and evaluate the results to obtain such a system. So, how do you we talked about, it is a integrated system of people, materials, information, equipment and energy. How to obtain such a system? To specify, to predict and evaluate the results of such a system, that is the second aspect of the definition. So, the degree of IE is evidenced by wide variety of activities. Okay. What are the wide varieties of activities? Example, okay, research in biotechnology, okay, development of new concepts of information processing, okay, then design of automated factories, okay, then formalization of incentive wage plans, etc. So, you can see that, I mean, few examples, you can even talk about research in biotech or development of new concepts in information processing. You can design an automated factory or formalization of incentive wage plans, etc. So, it is all across, you can see in one case it is design, other case it is installation, the third case it is the operationalization, the fourth case it is actually people and what you call as social sciences put together. Okay. So, it is a very diverse and wide field. Now, with this, once you have this basic understanding, let us talk about the goals of industrial engineering, some of the major goals of the IE. So, the first major goal that we usually say is help organization to achieve its goals, by planning its operation and contingencies. Okay. So, the first thing is you help or facilitate an organization to achieve its goals. Okay. How do you achieve its goals? By planning its operations and contingencies. So, the planning aspect is very critical as the first goal of industrial engineering. Second goal is improve organization's performance by increasing its productivity, quality and competitiveness. Okay. So, now second aspect is improve the performance of the organization by increasing the productivity, quality and competitiveness. And if you remember, I mentioned productivity as a ratio of output over input. Okay. So, we mentioned about the transformation process in the previous slides. So, this is the productivity aspect, that is how it comes into the second part. Now, third goal is improve effective utilization of resources and time. Okay. So, the second aspect is improve effective utilization of resources and time. Remember, we may come across a word called activity, or let us say call it as a task and job. Okay. So, task is an activity that need to be done, job is an activity with a start and end time. So, we will talk about how the resources and time comes into picture later down the road. And then the last one is eliminate waste. We talked about sustainability, how Toyota were looking into reducing and minimizing environmental impacts, etc. So, that is also, some people also call this as lean. Okay. So, eliminate waste. So, these are the major goals of the industrial engineering as part of this. Okay. Now, let us talk about the perspective, okay, perspective of industrial engineering. And this perspective is critical because other than the goals, okay, how did we reach here? So, the question we have is, the main question we will ask is, how did two words industrial and engineering got combined? Let us ask this question, how did it actually got combined? Okay. So, the history among this, it is a chronology of events. So, the first thing is principles of early engineering. Okay, where first taught in military academies, first taught in military academies. Okay. It had two forms, okay, two focuses. One is defense, the other one is what you call as road and bridge construction. That is why sometimes we call, in earlier days there are only two engineering, civil and military. Okay. That is how it was originally there to set up. Then next, okay, interrelated advancements. So, initially it was just military and civil, then the interrelated advancements in physics and mathematics, Okay. Supported practical applications or ensured practical applications of mechanical principles. So, we started developing what you call as, in a simple way to say it as, we started developing products. Okay. So, example, let us talk few examples. Telegraph by Samuel Morse, 1840. Then we can also call it as carbon lamp by Edison, 1880, etc. So, the advancements in physics and mathematics, interrelated advancements, they were related together, okay, drove what you call as practical applications of various principles, mechanical principles. So, Samuel Morse and Edison is two examples I said, where the actually product design came into picture. Then came the next one, science of chemistry facilitated what is called as understanding of the nature of matter and materials. So, science of chemistry or the advancements in the chemistry advancements, it helped us in understanding the nature of matter and materials. Okay. So, then because of all these kind of things, 5 major engineering disciplines, okay, they originated, okay, originated before First World War. Okay. Which were those 5? Okay. The one was civil, which was already there at the time, then chemical, okay. Then came electrical, then mechanical, and then the 5th one was industrial. So, these were the 5 major engineering disciplines that actually originated before the First World War, right. Then came the developments. Okay. So, this is 1, 2, 3, 4 and 5. Okay. The developments after Second World War. Resulted in engineering new disciplines okay, like which were the major engineering disciplines that came that time? Nuclear, then electronics, then aeronautical, and computer, etc. Okay. So, there is the First World War and the Second World War, the 2 landmarks. So, the first 5 civil, chemical, electrical, mechanical and industrial came before the First World War, and after the Second World War the 4 I just used 4 as an example, all other engineering disciplines that we see now came after the Second World War. So, now we see how the perspectives of the industrial engineering. Now, we talk about the origins of the industrial engineering. Okay. So, how did or who championed this? So, one of the first names we can talk about is Charles Babbage. Okay. He used factories in USA and UK, okay, Britain and UK in early 1800s. Okay. And what did he do? Systematically recorded their operations. Okay. He systematically recorded their operations. Okay. Details, that is what he did. Then number 2, what did he do was, then he measured the cost of performing each operation, Okay. He measured the cost of performing each operation and the time required per operation. Okay. To do what? To manufacture a unit product. Okay. If I remember that, it was 1 pound of gem clips, I believe, at that time. Okay. But what he did is, he measured the cost of performing each operation and the time required per operation, so that a unit product can be manufactured. Okay. That is what he did as a second part. Then what did he do? Then used this information, to demonstrate financial savings. By using women and children, okay, to perform low skill or lower skilled operations. So, the idea is that, remember that time the child labor was there. He said if you use women and children to perform lower skilled operations, then there is big amount of financial savings. That is what he demonstrated by using this data. Then the last one is, hence only operations requiring higher skill levels should be done by higher skilled and higher paid men. Okay. Do not think that it is a discriminatory thing, but what he basically showed that higher skilled and higher paid men should only work on operations requiring higher skills. Okay. So, this was a precursor of optimization. Okay. Now, people may cry foul saying that, oh, women and children, how can you make them work and do all those kind of things, but I am talking about 1800s. Okay. There was no child labor law that time, I believe. Okay. All right. So, this is how one of the way the optimization concept, which is very critical or core to the industrial engineering aspect. This started in this Charles Babbage study, where he studied factories and showed that he documented the cost of performing each operation and the time required per operation to produce a unit product, and show that if you use women and children which are lower paid to do the low skilled jobs, and higher skilled man is kept aside to do only highly skilled job, then you can actually achieve cost savings. Fair enough. Now, let us go to the origins of the industrial engineering. We continue some more of those topic as we discuss. Then came, after Babbage, then came Frederick Taylor. Okay. He identified potential improvements through work content analysis. People talk about time study and all, but let us be correct in this term. Okay. Work content analysis. So, what he studied was minimum work required to accomplish the task. Minimum work required to accomplish the task. Okay. So, the work content analysis of a job for maximum efficiency. So, he focused on maximum efficiency by doing or identifying the minimum work required to accomplish the job. Okay. Then the second person is Frank Gilbert. Extended Taylor's work. And what did he do? He identify, analyze and measure fundamental motions involved in performing work. You might have heard about the word called thermalics. Okay. So, he identified, analyzed and measured fundamental motions involved in performing work. So, lift, move, store. So, read thermalic. Okay. That is the reverse of Gilbert. So, he named it as thermalic. Okay. Then came Henry Gantt. Okay. What did he do? developed systematic graphical procedure for pre-planning and scheduling work activities. Review progress and update schedule. His Gantt chart is heavily used in construction. So, what it is, he developed a graphical procedure for doing pre-planning and scheduling of work activities, review its progress and update the schedule. It's still very popular tool in construction management. Okay. So, these three things again are landmark things in industrial engineering. Then in 1920s and 1930s, more fundamental work done on some of the other aspects. Okay. So, what were some of the fundamental things that were done on? Economic aspects of managerial decisions. Okay. If you take a particular managerial decision, what is the economic impact of it? That was the next one that was studied. Then came the inventory problems. Inventory in another way is how much of items, keeping items in stock, raw materials, finished goods, etc. So, inventory problems came up in the part of that. Then came up with incentive plans. Okay. If you do more work, more pay, kind of a thing. Okay. Or how to use incentives or to promote your thing. Then came something called factory layout problems. Okay. Which is where to place which machine, so that the flow and other kind of things is smooth. So, there are many things that came out of it, right. Then came material handling problem, okay. How do you do that? Okay. Then came principles of organization. Okay. So, in 20s and 30s, many of these aspects, okay, after the Frederick Taylor, who basically identified, he basically did work content analysis, as I mentioned, to achieve maximum efficiency. This is the minimum work required to accomplish the task, followed by Fred Gilbert, who extended Taylor's work to identify the fundamental motions involved in performing a task. I said read about Terblick. And then Henry Gantt, he developed the systematic graphical procedure for pre-planning and scheduling work activities, then review the progress of each of the work activities and update the schedule. And in 20s and 30s, more fundamental work came in, okay, which is in the form of economic aspects of managerial decisions. Then came the inventory problem, how much we need to keep in stocks. Then came in incentive plans, okay. Some people also call it as wage plans, okay. Work piece rates, there are many things that came as part of it. Then factory layout problems, where to place which machine. So, in this case it came at us what you call as a flow shop, job shop, assembly line, all of these came as part of this, okay, etc. Then material handling, forklift, overhead cranes, this, that, all those things. And then how do you organize the principle organization? This is the org structure, okay. The departments, whether you divide it by departments, by functional departments, this, that and all were actually part of this, okay. So, this covers, up to this point we cover the major thought process of involved in how the industrial engineering how the beginning from just two branches, civil and military, and within that how various advancements in various fields resulted in the development of the 5 basic engineering disciplines, and how where the industrial engineering came in before World War, before First World War, then after Second World War, what are the new things that actually came into picture, and how various seminal or pioneering work has resulted in the industrial engineering and what we look at today. We have already seen that. So, with this we will stop here, and we will continue how industrial engineering is related to other branches of engineering, in which fashion, and what are some of the major functions of it. We will look into the next presentation. Thank you for your patient hearing.